Let's see if it's working. Sheesh. Weird to watch my own stream. Let's see if it's working. Alright, I don't see chat, which is unfortunate. Let's see that. Yeah. Alright, I don't see chat, which is unfortunate. Let's see that. What? Well, now it can't connect to the AirPods. Ay, Dios mío. Let's turn off Bluetooth here. Well, now it can't connect to the AirPods. Ay, Dios mío. Let's turn off Bluetooth here. What is 2? Fuck. Oh god, oh shit. Oh no. Oh no. Can I get back to you? No, I forget, man. I'm sorry. Oh no. Yeah, do you got any other questions? Well, let's see. Let's show screen. Or let's... I have to whip out chat by... Oh, yeah. Do you want to be a mod? Sure. It's in live. It also has capabilities. Sure, why not? Alright, let's put a co-create thing on. And let's move to this. How does this look? I need another screen to be able to see stream. Is it not sharing? Where the fuck is this input? What the fuck? Why is it failing me? What happened to co-create cropped? Alright, let's move it here, see if it sees it. What the fuck? Joe, I need help. Yeah, the big black box is supposed to just be Firefox. Yeah, I don't have any, what's it called, set up. Shortcuts to change scenes. I'll put some of those up. I also don't have a second monitor to see the OBS with, but And also, if you look at the OBS, I don't have chat. Yeah. Joe, Google how to get YouTube chat on OBS. I know I've seen it before. What's studio mode? Studio mode? What the fuck? Well, this was supposed to have co-create and it did before. Well, I'm just going to remove this and do it from the beginning. So blackbots, let's add a source. macOS screen checker. I want to say a co-create source, or like a product source. I don't want to have to do this every damn time. What the fuck? Application capture. Yeah, let's do Firefox. What else? Chroma key chat background. Is that something through OBS that shows it? Okay. We got something here. We got something here. Shit. Wait, that's more than just Firefox. Why does it show the top of the screen? Okay, let's switch it to co-create so that I can adjust it so that's beautiful. So that's fucking beautiful. Eh. We'll do this. We'll do this. And then this. Oh my god. Fucking, are we cooking? Holy shit. My god, how does that look? I have to get the chat out. Does it still show co-create or does it show chat when I do this? I'm guessing it shows chat. Or like shows YouTube. Wow, the latency on YouTube is quite a lot. Or like I'm just seeing the end-to-end ping with myself. That's interesting. It's looking nice for you. Okay. Alright, Joe. Well, I'm also here to make promises come true if you have an actual math question. I guess I can do two if you really want. Or I can do something besides two. Ugh. Yeah, but I bet they'd be less delayed if I had the actual OBS chat thing. Alright, OBS Mac, get YouTube chat while streaming. Let's see. To add YouTube chat, obviously you can either use a service like Stream Elements or Streamlabs to create a chat overlay and add its URL as a browser source in OBS. Oh, to get chat overlay? Do I want chat overlay? I mean, I guess I could. Chat overlay is at least a way to see the chat sometimes. I just want to rechat. Rechat. YouTube. Bruh. Dynamic programming. Yeah, let's do dynamic programming. That's actually a great one because a canonical dynamic programming problem is the Fibonacci numbers, and dynamic programming is a really interesting topic because unlike pretty much everything else in an algorithms class. Okay, now I really don't see you. I want to see if you ask questions. Okay, how about let's get chat so you can ask questions during, and then I will teach you what dynamic programming is. Let me just open up OBS, see if there's a way to get chat. Properties? No. Let's go full cam again. And I've heard them, but never listened. I thought the canonical. That's one of them. But that's not the canonical one. Settings? Sure, settings. Appearance, stream. Alright, I'm just gonna ask ChatGPT. I'm sure it knows. Tell me to do something. Yes, ChatGPT, I would like the rest of the water in the Nile to figure out how to get chat from YouTube on OBS. See YouTube chat streaming. Yes, on Mac. Ideally, the Nile would never run again. If you can have that happen, ChatGPT. Pop out the YouTube chat in your go to. I'll have to go to live control. Option 1, option 2. Dock the chat inside OBS. Well, let's see what happens when I go to studio.youtube.com. Open link. Stream preview and a chat panel by the right side. I bet it's gonna be slow as shit though, right? Well, I'll try it, and we'll see how slow the chat is anyways. You'll see a stream preview and a chat panel on the right side. I don't see either of those things, but cool. Content. Let's see live. Live, okay. Don't see the stream preview. What if I just get chat on my phone? That's one way to do it. You know what? Because I'm universal answer guy, I'm down to get chat on my phone to do it. Pop out chat. Oh shit. Joe to the rescue? We thought it was Joe Mageddon, but it was Beautiful Joe? Holy shit. Well, let's try pop out chat. Okay, it's popped out. Let's see if I go back to co-create and I go back to the co-create scene how it looks. Co-create full screen. If I just put chat up, well, it actually, you know what? I can just avoid that area of the screen. I'll just put it under me. I'll make it a little smaller. I'll put it under me. Set it as screeny. And we'll just move this up a little bit. I just have to know not to write in that corner. That's fine. I won't write in that corner. Alright, what was the question again? Dynamic programming? Do you know anything about dynamic programming, or have you just heard this thing referred to before? Let's see. We'll go this. Oh, when I click on it, it fucking puts pop-out chat in the background. I'm gonna put you really low so I can only see one message at a time. Literally just, oh, it doesn't even show the full thing. Okay, literally just referred to. Okay, that's fine. Well, we're gonna do dynamic programming. Dynamic programming. Oh my god. The latency is on the order of 2 to 3 minutes. That's insane. There's no way that's the latency for all YouTube streams. Well, I'm gonna have to figure that one out. 2 to 3 minute latency? That is fucking insane. Well, if I look at it, okay, I can see where that's. There are graphs or something. Yeah, we could show a graph. Okay, we're gonna go over, we might just do one problem, which might be enough. We're gonna do calculating Fibonacci numbers. So dynamic programming, something you learn in a bunch of algorithms classes. And what's unique about it is that it's not a specific algorithm. It's not like a group of algorithms, it's a method of designing algorithms. It was invented by a guy named Bellman, and is memorialized in a Bellman-ford algorithm, which we actually could do the Bellman-ford algorithm. And we could do the Bellman-ford algorithm in Fibonacci numbers. That's actually not a bad way to do this. Because that would be the first dynamic programming problem, and he applied for a grant decades ago to work on programming stuff, and he just called whatever he was going to work on dynamic programming so that people thought he was doing something cool. Because the words dynamic and programming really have nothing to do with what dynamic programming is about. What dynamic programming is about is cleverly choosing subproblems to remember or to memoize so that your recursion doesn't redo work it doesn't need to. So we're going to start with an algorithm to calculate the Fibonacci numbers, and let's just do that. We'll write algorithms in blue. So let's do alg for fib of n. How would you calculate Fibonacci of n? Well, you'd say if n is less than or equal to 1, you just return 1. Else, return fib of n minus 1 plus fib of n minus 2. Okay, cool. This is not dynamic programming. So what's wrong with this algorithm? If you can name anything wrong. And I'm willing to wait the 2 to 3 minutes, Joe, for you to tell me what the fuck is up with this algorithm. Because I want to know. I want to hear from you. Because there is something wrong with this algorithm. It's not incorrect. It will give you the Fibonacci numbers. But it's slow is the answer. It's slow. What could be wrong? I don't know if I will wait for you. Maybe I'll have you call in. Oh, we can do it. Problem, the big problem is that this is slow as shit. It's so slow. Oh my god. It does recalculate a lot of stuff. You're right. When you're doing it, let's say we start with fib of 10. You know, we do a little fib of 10. What do we have to do for fib of 10? We have to do all this stuff. We have to do, you know, fib of 9, fib of 8, and then suddenly we're redoing shit. And it's like, what the fuck is going on? Because now we're doing fib of 8 again? What the fuck? Fib of... Get it? Because 7, 8. You get it. You get it. He gets it. I could have drawn this tree a little better, though. But that's fine. You have to do fib of 7 again. Fib of 6. And this grows exponentially. Oh my god. Exponential growth. Like 2 to the n calls. This is no good. Bad. Very bad. Because exactly what you're saying, you have to call this guy when you've already done this guy, maybe, or you will do this guy, and you're doubling up your work. So this gets to the first important theme of dynamic programming. So if we're talking what DP is, all my buddies love DP. DP, thing 1. I guess thing 0 is usually a recursive problem. But remember, useful info. It's about setting things up so that you remember. So let's do another page and let's do this better. We're going to do the DP version of DP Fibonacci. So what are we going to do? For Fibonacci, it's actually pretty simple. DP fib of n, if n is less than or equal to 0, return 1. And then, because we have to use memory, you have to say if fib of n, let's call it dp. This is what a lot of things do. If dp of n is not equal to null, we have some array, return dp of n. Otherwise, what do you want? You say fib equals dp fib of n minus 1 plus dp fib of n minus 2, and then you remember it. You say dp of n equals dp equals fib, and you return fib. So what are we doing? We establish some sort of array structure, which we'll use this color for. We establish some sort of array. And now what happens? Let's do the exact same calculation. Let's do fib of 10 and see what the tree actually ends up looking like. So we're going to do fib of 10, and we're going to go a little smaller. So that we have some room. We'll do fib of 10. Okay, that's a lot smaller. And what does fib of 10 do? Well, it asks for fib of 9, and it asks for fib of 8. But it asks for fib of 9 first. Well, what does fib of 9 do? It asks for fib of 8, which then asks for fib of 7. So we'll actually do it in order of like how the recursion would actually do it, which then asks for fib of 6, which asks for fib of 7. Wait, sorry, no, fib of 5, etc., and goes all the way down to fib of 1. You know, there's a ... in here. And once we go down that recursion, once we do fib of 10 and that fib of 9 asks for fib of 8, fib of 8 asks for fib of 7, you've done linear work. And then when you do the recursion again and you ask for fib of 8, that's already cleared. That's already in your DP array. This is the array DP. Like this guy is DP, our array. And so what does the recursion actually look like? Well, the recursion diagram looks like starting with fib of 10, and then you go down linearly to fib of 9, fib of 8, fib of blah, 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 etc., all the way down to fib of 1, which is linear work. And then you check fib of 8, and then the recursion stops because you remembered the answer. You checked fib of 8, and the recursion stops. So it takes linear time. And all of this because you remembered previous work. So that's the important thing about dynamic programming. It's exactly finding the right subproblems. In Fibonacci, it's easy. And remembering this information, usually in some multi-dimensional array, if I'm being honest. And then, you know, you've sped up your recursion from exponential to, what's it called? To linear, which is pretty good. All right, we're going to jump to, in algorithms classes, this is probably lecture 2 or 3 of dynamic programming, when you've already seen more examples, since this is a slightly harder example, but I believe in you. So we're going to do black text. We're going to do the Bellman-ford algorithm. Bellman-ford algorithm. No. Is the quick answer. It's like, oh, is Spider-Man the same guy as Spider Labs? No. Jesus Christ, Joe. Ask better questions. No, that's a fine question. Right, Bellman-ford algorithm. Fun times. So this is a more complicated problem. I wish I had an iPad to draw this, but I'll draw this freehand. It's gonna be beautiful. You have a weighted graph with nodes and such. Nodes and such. Yes, indeed. Look at this. It's beautiful. And they have edges between each other, and the edges have weights. Indeed. Weights 3, 2, let's say 1. And the question is that we're solving is APSP, all pairs shortest paths. All pairs shortest paths, yes, quite. Basically, what I want is that, say all of these nodes are labeled from like, 1, 2, 3, 4. I want like a lookup table, an IJ lookup table that tells me the shortest distance I to j in this graph. This is what I'm looking for. All right, Joseph, this is a much more difficult question. Can you tell me what the subproblems should be? Because the key to every dynamic programming problem is what are the subproblems? Because I'm going to do some recursive thing and I'm going to remember answers to subproblems. And once I remember all these answers, it's going to make it a lot easier. And so the question is, what is the subproblem? And once I've calculated all the subproblems, and the weights are the cost moving along the edge, yes. And the weights are all positive. But if you get really fancy, you can actually do this where there are negative edge weights too. All you need is such that there are no negative edge weight paths, and you actually have to correct your graph and do all pairs dijkstra. So, but that's fancier. We're not going to do that this lecture. Maybe another lecture we can do the same problem where there are negative edge weights too, because it's possible. It is possible, and it actually uses Bellman-ford as part of it, but only positive. You look at subpaths in your recursion. The shortest path between two nodes. Well, that's the answer. The answer is the shortest path between any two nodes. So if you have that information between any two pairs of nodes, you're already done, because that's what I'm looking for. This is a bad example of graph because I'm pretty sure... Oh, well, I guess there are multiple answers, but... So, what you want, I'll just tell you, because I don't want to delay forever, take up your time. We are going to have our table, our big DP. The juicy DP is this. It's going to be DP, I'll make it a little smaller, of I, J, and then I'll call it L. Ooh, I don't like L. S. Because it looked bad. And so what is this going to be? It's going to be the shortest distance between I and j. So far, there are different all shortest paths of length 1, length 2. Yeah, I think maybe you did get it. Of length less than or equal to s. And so this is what we're going to calculate. And so with any recursion, the first thing is you want to make sure there's a base case. Base case is pretty easy. dp of I, j, 0. What is this going to be? Well, it's going to be 0 if I is equal to j. and it will be equal to, can I actually do, I think I can. Sweet. If I is not equal to j. So that's our base case. So this is another thing to add to our DP. Remember, useful, make sure you have a base case. We're going to make this smaller too. Then we're going to do the third thing. Make sure you can calculate useful info with your existing info. So this is basically saying, what is the recursive step? So here, if we're taking our DP stuff, this is our recursive step by looking up in the table. We kind of put it here if you're looking at the flow of the program. But here, we look at the table. The first thing we do when we call this function is check this, and then we look up the table. What about here? Well, here, what are we going to do? So let's calculate dpij1. So we're going to fill this table with a bunch of infinities, is what we're going to do. And we're going to say, what is this? Well, this, I put my hands together and I go, yeah, oy, ah, I don't know. It's driving me crazy. How would you do this? Clipping that? Can you clip on YouTube? I think you can, right? Can you still? They take it away? Well, I'll just say. You're going to do this. First of all, it might be, the answer might just be equal to dpij 0, because just maybe we have a short path between the two things of length 0. So it has to be the minimum between dpij 0 and, you can't clip, and paths of length less than or equal to 1. And so how do we do paths of length less than or equal to 1? Well, we just check. Check all edges adjacent to j. And we take eja, and we check this. If e of j comma a plus dp of ai 0 is less than or equal to, our thing, because I'm going to make this a little smaller so that it fits. Cheating. Is less than or equal to dp of ij0, of ij1, sorry. And if it is, you reset it. dp of I of j1 equals e of j comma a plus dp of ai0. Okay, what are we doing here? I'm going to write the general thing too. So this is for 1. We can throw that out, and I'm just going to write it for the general case too. So here's the general case. Calculating dp of I comma j comma s. Well, you have to loop through all s, and so we're assuming, I'm going to say, assuming calced for all s prime less than s, so that we've already done some work. So we're looking up in the table. Well, we say min length equals dp of like we do with all recursion. If dp of I j s is not equal to infinity, then just return that. Return it. P of I, J, S. If we've already done the work. And then we do some calculating. So how do we find the shortest path of length less than or equal to s? Well, we say min length equals, maybe s minus 1 is enough. It could be enough. Who knows? And then loop through a adjacent vertex to j, say. So let's say this is our j. 3 equals, j equals 3. Then we could have a equals 4 comma 2. So loop through a adjacent to j and do the following. You know, d, the distance, is the edge length between aj plus dp of ia s minus 1, because we've used 1. And then you say if d less than min length equals d. And then once you've done all that, you fill in your table, you do your work, you make sure you're writing shit down, and you say dp of ijs equals d, equals min length, and then you return min length. So what's going on? The full algorithm for doing this, for finding the whole path, you can also do this algorithm for maximum length paths. Actually, can you do that? Let me think about that for a sec. Can you do it for max length paths? Oh, but there might be infinite loops. I'll think about it some other time. So what you do is you iteratively, the full algorithm is loop through s equals 1 to n, where n is the number of nodes. Calculate dpij s for all I comma j, and then output dpijn. And, you know, this is not the most efficient. I haven't done Bellman-ford in a while. This will give you n to the 4th. I bet you can, actually, even potentially n to the 5th, because you're looping through the adjacent edges. But I bet you can do better by optimizing some of the min-length calculations, because I did this a little sloppily. This was just sort of off the cuff. But it does give you a recursion that gives you a polynomial length answer to give you the all pairs shortest path, which if you do it with dijkstra would take n squared log n, which is a decent amount better. I bet you can get this to n cubed with dynamic programming. But does this make sense? Or was I just going through it too quickly and just yapping nonsense? Let's see. I can switch to full cam. Maybe I should leave it up. How I can keep this. But yeah, the general gist of dynamic programming is that you want to keep things. You know, I used dynamic programming the other day. Here's another problem you can use dynamic programming for. This is me using dynamic programming in the wild. Suppose I have a sack. We're doing DP with a sack now. Anyway, that has different colored balls in it. You know, so I have some red balls. Some days I get blue balls, some black balls, some green balls. So I have R red balls, B blue balls, K black balls. I got into trouble there. And G green balls. Here's a question. What is the entropy of drawing a random length and sequence of balls from this sack, where n is less than r plus b plus k plus g? What is the entropy? You can do this in technically pseudo polynomial time. And this is kind of hard if you've not seen entropy, so I might give like a... What should I give? The entropy, let's say, and we write entropy by h. I'm going to give a key equation for entropy. I'll make this a little smaller. Here's a key equation for entropy. Put in green because it's important, and make it big. We're going to say h of one draw is equal to h of oh, am I gonna get this right? I need a given. So okay, let's say h of, maybe I'd need to think about this. Maybe I have to write down some equations. What are the entropy equations? Well, let's just review entropy equations while we're here. We know h of xy, two events, is equal to h of x plus h of y given x. I think this is what we want. Because, yeah. If we're given x, yeah, this is the equation we want. Okay. So h of that we draw, oh, I have to average over x. Yes, okay, right. So therefore, h of length m sequence is equal to, well, what's it equal to? It's equal to the entropy of drawing once, which is our h of x, and then it's equal to the entropy of a length m-1 sequence given one draw. Make that smaller. So what does this mean? This means that we can do the entropy of just drawing from one ball, and then we can recurse down to length n-1 sequences, but you might notice that you have the one draw, and so you actually have to average this over all the different draws. And so this term, the second term, is where your recursion will start, and it will depend on which ball. So there will be 4 summands, and that will give you 4 different m-1 sequences. And so your recursion will, your DP array will have the number of reds left, the number of blues left, the number of blacks left, the number of greens left, and the number of balls left to fill out a sequence. And h of draw once, you'll have to calculate directly. And so I actually wrote this program, I don't know, a week ago. And I used dynamic programming to be able to calculate sequences and the entropy of sequences. I'm guessing this part was less sensical because I gave less details and a lot of people have not seen entropy. But this is just to say that, dynamic programming does come up. And so if you see, I guess for you, some programming problem where you have a recursion that seems to be exponential, but you notice that it feels like some parts of this exponential recursion are using information more than once, it probably means you should use dynamic programming somewhere. But anyway, so yeah, dynamic programming does come up. Um, it's ironic though, because I did this for like a problem set problem, and when I finished the problem and I did this calculation, I realized, wait, there was a way easier way to do this. So this is the problem with knowing some programming and knowing some mathematical programming, is that I see the problem and I know like in an instant, because I know dynamic programming, I know some other stuff that's like, oh, I can write a program that will do this. And if I write the program, it'll take somewhere between 30 minutes and an hour. And it's hard to like keep, I guess, thinking, even though if I saw this one simple observation, I would have got it very quickly. Um, and so I just spend the like 30 minutes to an hour writing the program, and then I get the answer. But but yeah, so dynamic programming does come up. This was a place that comes up related to sequences like Fibonacci. Um, yeah, but let's change cams back to full cam. Restore chat. Oh yeah, popped it out. All right, Joseph, what did you think of the stream? Now I'm itching my nose a lot. It's all itchy. Need like nose spray. Ugh. Pivot, reverse, fair, dare. But miss the F smash. Huh? Alright. Well, I might just do these streams. Because I could keep this VOD and be like, call it the worst. Yeah, no, I want to add a lot more stuff. This setup is real, real ass. this, this is quite the jank setup. And remember to read the question. That's a fair point. But yeah, no, I also want to do just reacting to math videos. So I can just talk about shit, or science videos. But it is fun to just get a question like, what is dynamic programming? Because I can't just talk about that. But I don't know, maybe you should write the useful things. Way to see chat, way to react to videos. I guess a way to see OBS, because I have the monitor you got me, so I could hook it up to that monitor. Yeah, math react content. Like just watch some shit and be like, yeah, this is what I think. Or like, yeah, I don't know, I think that's kind of silly. But at least I can stream. So I just want to make a list of shit. Actually, you know what? We'll go back to co-create and we'll make list of shit. Sound good? I'm gonna pop out chat again. Larger streams get less latency. Really? They do that? Damn, that's a holy shit. So they're like, your ass, get this fucking latency, L nerd. No way. Are they L nerding me? Oh. Clapper. Anyway. Alright, list of shit. We're doing red, purple. Purple. List of stream things to do. Easy shortcuts. OBS to change scenes. A way to see chat in OBS. Less sure on YouTube, but yeah, I think partners, larger streamers get priority bandwidth. I feel like I should get... I'm like 6'4". I'm a big streamer. Give me priority. Um, and boss in OBS. Get a camera? Question mark. Get another. Oh, how does it sound? Like, how's the audio of me talking? Get microphone on. Use iPad to write stuff and or do problems. Oh, have a whiteboard setup scene. What else does Streamer need? Oh, a scene for reacting to math videos. Let's do that. Let's do that. Math, yes, etc. videos. Oh, we can hear typing sounds though. Typing, that's what you're here for. ASMR as fuck. This is what you are here for. I am on Mac. What, do you want me to whip out Peak? Huh? I would whip out Peak if you ever played it with me. Ungrateful. Scene for reacting to math videos. I mean, this seems good. Alright. But I'll head out there, see if anybody... I'll probably leave this up. So if anybody comes across this and wants to see it,